Linear versus quadratic. If you're looking at a table, you got to find the pattern. The pattern and how fast it grows and changes is what gives it away. So let's look this first one. If you start looking at your outcomes right here, and you see how fast they grow. So 4 to a 7, that went up 3 times. 7 to a 16, that went up 9 times. 16 to a 31, that went up 15 times. And then from a 31 to a 52, that went up 21 times. 52 to a 79, that went up 27 times. So it's growing, but it's growing at an increasing rate. So let's take it out again. From a 3 to a 9, that went up 6. 9 to a 15, that went up 6. 15 to a 21 went up 6. 21 to a 27 went up 6. So I know this one's quadratic. This guy right here is the quadratic, because your second change is constant. That means it's the same every time, plus 6, plus 6, plus 6. So it's increasing at an increasingly constant rate. This one then's got to be the linear. 4 to 7, that was up 3. 7 to 10 is up 3. 10 to 13, up 3. 13 to 16, up 3. Okay, this guy's linear, because it changes at a constant rate. Changes at a constant rate. What if you're looking at an equation? Which one of these is linear, which one's quadratic? This is the giveaway right here. You look at the exponent. The biggest exponent is 1, the biggest exponent is 2. This is the quadratic. So it's a pretty easy giveaway. You just look at exponents. This one is linear. Okay, here's what you know about linear. The exponent tells you how many solutions there's going to be. There is only going to be one solution. Quadratic, the exponent is 2. That means there's going to be 2 solutions. Okay, so let's solve the linear equation. Let's just undo it. You gotta undo the times by negative 3, and you gotta undo the minus 4. Undo the minus first. Plus 4, plus 4. So you're gonna have a minus 3x equals 24. Divide by minus 3, divide by minus 3. X is a minus 8. Okay, now over here there's gonna be 2 solutions. And this has a kind of a totally different approach. You've got to factor them. That's what we've been doing. So let's get everything on the same side. Let's take this 6 over. Let's minus 6 minus 6. So you got x squared minus 3x minus 10 is 0. And now you're going to use this 0 in your favor. Because if you can rewrite this as a multiplication problem, then we're set. It's going to be a piece of cake. So here's what you're looking for. Are there 2 numbers that are going to multiply and give you a negative 10, add and give you a negative 3? Those 2 numbers are a negative 5 and 2. So negative 5 times 2 is negative 10, negative 5 add 2 is negative 3. So you're going to write this as the product of 2 factors. So you're going to multiply and you're going to end up at 0. You're going to multiply x minus 5 and x plus 2. And the only way you can times and end up at 0 is if you times by 0. So the logic tells you, well, if I times by 0, one of these groups has to be 0. So what would you plug in this first group for it to equal 0? You'd plug in a 5. What would you plug in this group? You'd plug in a minus 2. So there are my 2 solutions. Linear versus quadratic in a graph. How do you tell which one's linear and which one's quadratic? Just by looking at the graph. Okay, this is your linear, and your linear graphs hopefully from your 8th grade, 9th grade days. You find M, you find B. M is the slope, how fast it's changing. This is changing a minus 3, and slope I remember as rise over run. So I'm going to make this a fraction. So it looks like rise over run. So my rise is -3, my run is 1. B is the number all by itself. B is a -4. B is your first dot. B is your y-intercept. So on the y-axis at -4, I've got a dot. Then I just use my rise over my run, how fast it changes. It changes every time it goes down 3, goes over 1, down 3, over 1, up 3, left 1, up 3, left 1. So kind of fill in the dots. Your line, a linear line, is straight. It goes forever in both directions. Okay, now a quadratic. This one we've done a few weeks ago, and it looks like a parabola. It's going to look like either a U or it's going to be upside down. Okay, the parabola, you need to know a couple things. What influences the shape of the parabola are these numbers right here. This number, and this number. This is your A, this is your B, this is your C. A happens to be 1. So A is 1, B is 4, C is 5. And just like in this guy right here, your first dot is your -4. That's your y-intercept. That's the exact same on this one. The number all by itself with no variable, that is my first dot. That's the y-intercept. So on the y-axis, I put a dot at 5. Okay, now on quadratics, on parabolas, here's what you know. These parabolas are symmetric. They're perfectly symmetric. So I want to find that line of symmetry. I want to find that dead center. To find the dead center, you're going to use this. -b divided by 2 times A. So now let's plug in our values. -4 divided by 2 times 1. It's going to be -4 divided by 2, which is just going to be a -2. So my parabola is symmetric about -2. So here's what I know. I get a dot for free. I got that dot there that reflects across the line of symmetry. I've got a dot right there. Okay, now I just need to find this. I just need to find the highest or lowest point of my parabola. I need to find the vertex. The vertex, let me erase some stuff. Okay, the vertex, if you make your table, an X and a Y table, you're going to plug in this -2 for X. You're going to plug in a -2, and whatever spits out, that is going to be your vertex. So you're going to plug a -2 in there for X, in there. So you're going to have a -2 squared plus 4 times a -2 plus 5. Okay, on the calculator, if you do not put this in parentheses, it's going to give you the wrong answer. A -2 times a -2 is a +2. 4 times a -2 is a -8, and then plus 5. So what's 2 minus 8 plus 5? 2 minus 8 is a -6. -6 plus 5 is a -1. So there is my vertex right there. When X is -2, Y is -1. So I'm going to go left 2, down 1, and my parabola is going to go and look something just like that. Okay, now what about this one? Choose 4 numbers and their opposites. Plug them into the function, plot those 8 points onto the graph, study the table and the graph, and explain why quadratic functions are symmetric. So I'm going to choose 4 numbers, 1, 2, 3, and 4. Choose their opposites, -1, -2, -3, -4. Okay, the rule, this is the father of all quadratics. This is the parent function. So if I plug 1 in, 1 times 1 is 1. If I plug 2 in, 2 times itself is 4. Plug 3, 3 squared is 9, 4 squared is 16. Okay, now what's interesting? If you plug a negative in, a -1, what is a -1 times a -1? It's still a +1. What's -2 times -2? It's +4. -3 times -3 is +9. -4 times -4 is +16. your symmetry comes from the exponent, because what number squared is going to give you 16? Well, there's going to be two answers. 4 times 4 is 16, or a negative 4 times negative 4 is also the same number. So you're plugging in two totally different numbers, but you're getting the same answer. You're getting 16. That is why they're symmetric. So if I plot these dots, if I go over 1, up 1, over 2, up 4, over 3, up 9, over 4, doesn't fit, 16 somewhere up there. Left 1, up 1, left 2, up 4, left 3, up 9, left 4, up 16. And I know this one. I know the vertex is at 0, 0. If I plug 0 in, I get 0 out. So that is my vertex. Your parabola is totally symmetric about 0. Why is it? It's because when I plug a 3 in, I'm going to get a 9. But when I plug a negative 3 in, I'm still going to get a 9. So the symmetry comes from the square. Okay, the zero product property. Let's solve this one. Let's get everything on the same side. Minus 10 minus 10. You got x squared minus 5x minus 14 is equal to 0. Okay, this is the zero product property right here. If you can, now the product is multiplication. So if you can transform this into a multiplication, you're going to use your logic and say the only way I can multiply and get 0 for an answer is if I times by 0. So the question is, does there exist two numbers that times give you negative 14, add and give you negative 5? And with a little bit of times table skills, you say, yeah, 7 and 2. But they got to add and give you minus 5, so it's going to be a minus 7. So you are going to change this to a times problem. It's going to be x minus 7, x plus 2. Your answer is 0. So the logic says one of those two groups has to be a 0. So what would make this group a 0? If x equals 7. What would make this group a 0? If x equals a negative 2. Okay, now use this equation to demonstrate the skill of the square root property. So you still got to find the answers, but we're going to use a different approach. Explain in great detail the logic behind why you would want to use this. Okay, your quadratics are ax squared plus bx plus c equals 0. Now this one right here is totally missing the bx. There is no x. There's just a squared right here, and then there's just a number all by itself. There's actually two of them, but there is no x. If there is no x, that's actually pretty sweet. All you're gonna do is take square roots. So you are gonna undo this equation. You're gonna undo the minus 6, the times by 4, and the square. Undo the minus first. Plus 6 plus 6. 4x squared equals a minus 32. Undo the times by 4. Divide by 4, divide by 4. X squared equals a negative 8. Okay, now undo the square. And this is where the square root comes in. Square root this, square root this. But we just learned anytime there's a square, there's going to be two answers. So it's going to be the plus or minus square root of a negative 8. Okay, now this is actually impossible. There is no such number times itself is going to give you negative 8. So you're now in the world of imaginaries. So you got x equals plus or minus. How you deal with imaginaries? Take out the imaginary. It's going to be square root of a negative 1 times square root of 8. So it's going to be x equals plus or minus square root of negative 1. That is your imaginary. So let's abbreviate it with the lowercase I. Okay, square root of 8 I know is this. It is 2 cubed. So you're going to pull a 2 out, and a 2 stays in. So your best answer is plus or minus 2i times the square root of 2. Alright, number 7. Okay, what if we go backwards? What if we give you the solutions? Can you write an equation in standard form, ax squared plus bx plus c, but a, b, and c have to be integers, so no fractions. Okay, if your answer is 7, or if your answer is negative 2, here's what it's going to look like. Okay, you're going to plug a 7 in right here, and you're going to get a 0. So how do you get a 0 if you plug a 7 in? It's got to be like this, because 7 subtract 7 is 0. You're going to plug a negative 2 in. How are you going to get a negative 2 to become a 0? You're going to add 2. So you're going to have x plus 2. So if I plug 7 or negative 2 in, I'm going to get zeros. Now let's multiply forward. X times x is x squared. X times 2 is 2x. Minus 7 times x is minus 7x. Minus 7 times 2 is minus 14. X squared minus 5x minus 14 is 0. There we go. What about B? What if your answers are 0 and 3? Okay, if I plug 0 in, how do I get 0? So it's going to be x plus a 0, because 0 plus 0 is 0. I'm already at my 0. So 3, what do I do to 3 to get it to be 0? I minus 3. So it's going to be x minus 3. Now x minus 0 is just, or x plus 0 is just x. So here's what you got. Multiply forward, you're going to have x squared minus 3x is 0. Done. Okay, now the fractions, they're a little bit more complicated. So there's kind of a cool pattern. So what are you going to do to minus 1 to get it to 0? You're going to plus 1. So you got x plus 1. Okay, now 1/2. 1/2 is going to be this. Okay, 1/2. If I take, it's going to be this, 2x minus 1. So the 1 and the 2 and the 1, they show up, and that's always the case. If this was 3/4, it would be 4x minus 3. So it's kind of a cool pattern. Your numerator is always going to be that one, your denominator is going to be the coefficient. So look, let's check it out. It's going to be 2 times whatever you plug in. You're going to plug in 1/2. 2 times 1/2, and then minus 1. 2 times a half is just 2 halves. 2 halves is just 1. 1 minus 1 is 0. Now you just multiply forward. So it's going to be x times 2x, that's 2x squared. X times minus 1, minus x. 1 times 2x, 1 times minus 1. So it's going to be 2x squared plus x minus 1 is 0. And you're done. What about this last one? What minus 3 is 0? It's got to be x plus 3. What plus a third is 0? X minus a third. But they don't want any fractions. They want integers. So let's use our sweet trick. Okay, what am I going to do to a third to get it to equal to 0? I'm going to have to minus a third. So here we go. If I times it by 3, 3 times a third is just 3/3, which is just 1. And then I'm going to take away 1, because 1 minus 1 is 0. So here's I'm going to do 3x minus 1. Your denominator always goes here, your numerator always goes here. Equals 0, multiply forward. 3x squared minus x plus 9x minus 3. So it's going to be 3x squared plus 8x minus 3 equals 0. Okay, I'm going to stop it here and cut it in half. We'll do a part 2.